Now we will discuss the different types of magnetic materials and hysteresis curve. So based on the magnetism induced in the materials are mainly classified into three types. One is paramagnetic, diamagnetic and ferromagnetic. So if we just talk about the paramagnetic material, so let's say that this is nothing but the substance of your paramagnetic material. So that is mostly a conductor for that copper and nickel. So when I just placed in some external magnetic field, the magnetic moment inside this your material, so they just try to align themselves in the opposite direction to that of your external magnetic field, and they just try to weak that or try to reduce that external magnetic field. So they just orient themselves in the opposite direction. So that we can call it as a paramagnetic material. So overall the magnetic field is going to reduce in this case, and it will just move from that stronger part to the weaker part. So this is nothing but your paramagnetic material that I can say, and you can say that it is hardly you can just magnetize this. If you remove this external magnetic field, definitely you can say that it will get demagnetized. So that you can say about this paramagnetic material. Then if we talk about this diamagnetic material, so in case of diamagnetic material, the same thing, but that is nothing but, so the magnetic moments, they are just going to align themselves. So this is nothing but the magnetic moments. So they align themselves in the direction of this external magnetic field, and the resultant magnetic field is going to increase. Yeah, so definitely they will just add their own magnetism into that. So definitely the overall magnetism is going to increase. So that we can call it as a diamagnetic material. In case of ferromagnetic material, so they are highly magnetized. So definitely their magnetism induced. So definitely all that your dipoles, they orient themselves in the direction of your magnetic field. Yeah, and it is highly magnetized. Yeah, so for example you can say that iron, so in that case, so it is highly magnetized and the value of your B is going to increase. So these are the ones, so we are just mostly using for making of your that electromagnets and all these things. So this is nothing but the ferromagnetic material. Now we will discuss the magnetic material along with their hysteresis curve. So this hysteresis means actually it is nothing but the kind of logging, that is nothing but a lagging, you can say that. So definitely from this diagram also you can say that the B is going to lag with respect to that H. H is nothing but the magnetic field intensity, and that B is nothing but that magnetic induction, we just said that. So now what you can see from this, so let's say for this first part I just consider some ferromagnetic material and I'm going to magnetize it. So definitely I just apply or I will place it some external source of magnetic field. So it will just get induced of your magnetism. Then you can find that this B goes on increasing as I increase the value of H, but after that even if I increase the value of H, the B remains constant. So that is the point of your saturation, you can say that. Now again if you demagnetized it, so again from that saturation it will come at this point. So let's say this is one point of B, and at this point B, which is nothing but you can say that it is a retentivity. Even though I make the value of H 0, but still the value of B is not equals to 0. So this portion you can call it as a retentivity. So that means even if I make H 0, but still that material is magnetized. So to make that demagnetized completely, I will just again apply that magnetic field in exactly opposite direction. So at this coercitivity or at point C, you can say that definitely the value of your this B becomes 0, but you have to apply that external electric field exactly in this opposite direction. Again further moving in the downward direction, so again if you increase that H in the opposite direction, once again you will reach that saturation point, and again you have to just change its polarity. It will go through this another graph. So again that is from D to E, E to F, again F to that saturation point. So it is not exactly following the same line or same path. So definitely you can say that B is lagging as compared to that H. So that's why it is called as a hysteresis. So that is a lagging somewhere. So it is again the relation between them is given as B is equals to mu into H. So this is how this hysteresis curve works for your ferromagnetic material.